Hello, everybody. Welcome back to another discussion dynamics. Today we will close our kinematics of rigid bodies. We will close it with acceleration analysis subchapter. And today we will just do very brief lecture review and then 2 examples. So without further ado, let's dive straight into our discussion. Brief lecture review. So please assume that we have a rigid body. Okay, something like that. Let's specify 2 points on that rigid body. Let's say point A and point B. Point A and point B. And let's say that we know acceleration at point A. We know also omega of the body. And we also know acceleration of the body. I mean angular acceleration, yes? So these are our knowns. AA, alpha body, and omega body. Okay, plus of course we know the entire geometry, yes? We can measure this distance. So we obviously also know this vector R, B with respect to A. So just in case you would like to calculate AB, you can use this expression. AA plus alpha body times RBA minus omega body squared RBA. This is for 2D motion. This expression is valid for planar motion. And we will use it today 26,000 times. Okay, this is equation we are going to use many times today. Okay, any questions to the brief lecture review? Okay, I would like to do example number 1. As usually, please read and understand problem statement before we start our solution. Okay, but as usually, I expect that you familiarize yourself with these problem statements before coming to the discussion, yeah, so that we don't spend time on reading and understanding. Yes. Okay, so what do we have in here? We have 3 bodies. Yeah, we have our disk. We have our bar BC, and we have our little bar CD. Okay, we know the entire geometry of the system. And they also told us that, they also gave us every single information about the disk. And by every single information, I mean that they gave us omega of the disk and alpha of the disk. Yes, they are given here in the magnitude form and here vector-wise. We know that omega disk rotates clockwise and alpha disk is oriented counterclockwise. And they ask us to find, I believe, alpha of this disk. So let's already assume it. Let's already assume that it rotates counterclockwise. So they ask us to find this value. Alpha alpha CD. Let's assume that it rotates counterclockwise. So it's the other way around, yes? My mistake. So this way. Okay, and in the pre-class assignment, I run velocity analysis for that system, yes? And these are our findings from that velocity analysis. We know what is omega BC, and we also know what is omega CD. So we know omega of these two links. And that was the whole point of running velocity analysis. So I just would like to say the most important sentence of today. So even if you are asked to find alpha of the body, so angular acceleration, that doesn't mean that you should dive straight into acceleration analysis. Okay? That means that because usually velocity analysis is required before acceleration analysis, okay? So even though you are asked to find alpha of the body, you should first run velocity analysis and then acceleration analysis. Was that clear? Yes? Okay, that's why I pre-recorded video. Okay, and today, since we in the pre-recorded video, we run velocity analysis, today we can focus entirely on the acceleration analysis, okay? So let's do it. So I would like to run acceleration analysis between these points. Between F and E, then B and F, then C and B, and then D and C. We must do it 4 times for this mechanism in order to figure out what is the answer to the question. So I will just follow this linkage. I will just draw it in the picture. So we will start from here. We'll go here, then we will go here, then we will go here, and we will end up here. Okay, so this vector is RFE. This vector is RBF. This vector is RCB, and this guy will be RDC. Delmi, can I ask you to close the door? Yeah, thank you. Okay, so yeah, thank you, sir. Also, okay. So now let's write our expression from the previous board. AF is equal to AE plus alpha of certain body times RFE minus omega squared of certain body RFE. Okay, so I will just copy this expression 4 times. Sorry, I will copy it 3 times. Yes, and I will just change the subscripts so I can do. And you guys think of what certain bodies we should put there. Okay. A couple of typos on the board. I will correct them. Don't worry. So first of all, I must put vectors here. And that was DC, yeah? Okay, and I have to get rid of these subscripts. Okay, so in here I will just put B, F, B with respect to F, B with respect to F, C, B, C with respect to B, C with respect to B, D, C, D with respect to C, D with respect to C. Okay, guys. So can at least one of you tell me what subscript I should put here? Omega of what body and alpha of what body is here? Hamilton? Disk, exactly. Yeah, because F and E belongs to disk. So it will be disk. Yeah. B and F also belong to disk. Yeah. CB belong to bar CB, so it will be alpha BC and omega BC. And DC belong to another bar, so it will be bar CD and bar CD. Great. Let's number our equations. One, two, three, four. Roman numerals, and let's start from the beginning. Okay, let's do it in the wild way. Let's start from beginning. Yeah. Okay. So I'm just gonna copy this expression. So, can you guys tell me something about these two quantities? If you look at the picture, what you guys can tell me about these quantities? So, first of all, AF, they both will have 0 in the Z component, yeah? Because this is a planar motion, 0, 0, yeah? But can you please tell me what I should put here? AFX, AFY, AEX, AEY. So can you figure out at least one or two of them just based on looking at the picture? So let's focus maybe on point E, on this point. Can you tell me something about acceleration of point E? Can you guess any of these values? Tell me. Which one? Both 0. Partially true, 50% true. Only this one is 0. Sorry, only this one is 0. Because the trajectory of point E is following. Is here. Do you see? Our point E, our disk rotates, yes, rolls on the ground. So our E cannot leave that ground. So that means that it only can, that Y component will be 0. Do you see that? Okay. How about this one? Can you tell me something about AFX and AFY? So acceleration of this point, contact point between disk and ground, and there is no sleep condition. Scott?
Yeah, wouldn't it be 0 for both?
For both. Yeah. Partially true, 50% true. This one would be 0. For no sleep condition, only this one is 0. The other one we don't know, yes? For velocity, if I ask you for velocity of that point, you will be right. Velocity of point F is 0. Yes, velocity of point F is 0, 0, 0. But due to no sleep condition, however, this is a very common mistake by the students actually. So when we talk about acceleration and there is no sleep condition, only X component is 0. Okay, the other one does not have to be 0. Okay, keep that in mind. Great. Okay, and now let's continue. Plus alpha disk, I think it was given. Let me scroll up the board. Yeah, it was 2, 0, 0, 2 times this vector. Let me scrub the board. RFE. RFE is here. So that would be 0 minus R0. Yes? 0 minus R0. Minus omega squared. What was omega of the body? Minus 4. Minus 4 squared. 0 minus R0. Okay, we must do this determinant. So that would be ijk 0, 0, 2, 0 minus r 0. By the way, what was r? 2 also. Okay, so I'm going to put, instead of r, I'm going to put 2 in here. So this will be 4, 0, 0. Okay, so now we ended up with 0 AFY 0 is equal to AEX plus 4 minus 32, 0. Yes? So we know from here that AEX will be minus 4 feet per second square. And from here we know that AFY is, I made a mistake, it should be positive 32. Otherwise it doesn't make any sense. Okay, where did I make a mistake? It will be just here. It will be positive. Yeah, it must be positive. Okay, great. So we found our vectors of these 2 points. AE will be minus 400 feet per second squared, and AF will be 0.320 feet per second squared. Yeah, as you can see, Scott, it's not 0, 0, 0. It's 0.320. Yeah, it's actually easy to explain. You probably already see it. This point F must have centrifugal acceleration. Yeah, towards the center of the circle. Perfect. Yeah. Okay, so we're done with our first part of the problem. Now let's do acceleration analysis between B and F. So now this one. So AB will be equal to that's what we just found, 0.320 plus 0.02, yes, times this vector. Okay, we must figure out that vector. So I'm going to scroll up the board again. RBF. Aha, RBF is here. So its component will be R0, I believe, yeah. So it will be 220 minus 4 squared R0. Okay, our determinant is here. IJK 002 RR0, and this is equal to minus 2R to R0. So it will be minus 440. Okay, so our AB is equal to minus 4 minus 32 plus 4 minus 32. So that will be equal to 3640 feet per second squared. Great, 50% of the problem done. Any questions so far? We're gonna do exactly the same thing twice. Twice more time, yeah, okay. So this is done. Now we're gonna repeat for the 3rd time exactly the same thing. Velocity acceleration analysis between these 2 points right now. Okay, so we will have AC is equal to minus 3640 plus omega of this body that is unknown, but let's assume that this is positive direction, okay, 0, 0, alpha BC. So just assume positive direction. Assume counterclockwise direction times this vector. Okay, again, I must scroll up the board and figure out what are the components of this vector. RCB. Aha, it will be this long vector, right? It will be this long vector. And we know that the slope is given by 3 units to the downwards and 4 units towards right. Yeah. Okay. So I think I did it in that video I pre-recorded before this discussion. So the easiest way to find the components of that vector is to basically multiply this guy by 2. Yeah, because you remember this Pythagorean triangle. Yes, its sides are 3, 4, 5. Yeah, if we multiply this guy by 2, we'll end up with twice as big triangle, 6, 8, 10. Yeah, and by the way, they told us that this vector has length 10. If I scroll up the board, you can see that they told us that L is 10. So our RCB is basically this vector. This is our RCB. Okay, so its components are 8, minus 6, 0. Any objections? Any questions? Okay, cool. Minus omega BC. Aha, we found that omega BC in our velocity analysis, yes? We ran before the discussion. Okay, so it's gonna be 1. It's 1 squared. 1 squared. And we found it in velocity analysis part. We found it in the velocity analysis part. Okay, and in here we will have exactly the same vector. 8 minus 6, 0. Okay, if you run this determinant, you will obtain that this vector is two alpha. Oh, sorry, no. This will be 6 alpha BC, 8 alpha BC, 0. Okay, let's put together our AC now. So our AC is equal to minus 36 plus 6 alpha BC minus 8. And here we have 4 plus 8 alpha BC plus 6, 0. So we'll end up with minus 44 plus 6 alpha BC and 10 plus 8 alpha BC, 0. Great. And we are done with 75% of our problem. We cannot squeeze anything more so far. Yeah. We must leave AC in that form right now. So in the last part of our discussion, we'll just focus on acceleration analysis between these 2 points, D and C. This is 4th part. Okay, and maybe before we just start talking about this, is everything clear so far? Yeah. So if it is clear, can any of you tell me what is acceleration of AD? What is acceleration of point AD? I can even scroll up the board. What is acceleration of point D? Yeah. And why? Because it is fixed. Yes. Perfect. This is point D here. Just for those of you who are watching that at home. Okay. So this is 0. Vector, of course, yes. D is fixed. Okay. So we will have 0 vector is equal to this vector we just found. Plus value we don't know, 0, 0, alpha CD. Remember to assume positive direction times this vector. Okay, so for the 4th time, I'm going to scroll up the board and we're going to find RDC. This is this little vertical vector, and its components are 0 minus H0. 0 minus H0 minus, dang, I have to scroll up the board once again, omega CD. What was its value? Aha, it was 7 or minus 7. It doesn't matter because it's squared anyway, yeah. So it will be minus 7 squared times 0 minus H0. And H was 2 feet again. Okay, if we run this determinant, we will obtain that this is equal to 2 alpha CD 0, 0. And if we put together our expression, we will end up with 0, 0, 0 equal to minus 44 plus 6 alpha BC plus 2 alpha CD, 10 plus 8 alpha BC plus 98. We can simplify our expression. Okay. And now we see that we ended up with 2 equations and 2 unknowns. Yes. So we ended up with 8 alpha BC plus 108 equal to 0. And 6 alpha BC, 2 alpha CD, minus 44 equal to 0. Okay, if you solve these 2 equations and 2 unknowns, you will end up with alpha BC equal to minus 13.5 feet per second square, and alpha CD equal to positive 62.5 feet per second square. Great. And vector-wise, alpha BC will be rotating clockwise, and alpha CD will be rotating counterclockwise. Okay, and this is our answer. Questions? I have a question. Is it tedious? easy but tedious. Yes. Yeah, and with that approach, you can solve any single problem. If you're asked for acceleration of mechanism or acceleration of rigid body, if you use this approach, you can. It's easy but tedious. Yes. Yeah. I bet you will solve any of such problems. Yes. Also on Wednesday, I showed you like velocity analysis. So the counterpart of what we did today, yes, but for velocities, yes, plus instantaneous center of rotation approach. Which one you prefer? Yeah, I also so I prefer this one, even though it's tedious, but it's kind of like automatic. Yeah, it's very hard to make a mistake, in my opinion. Yeah. Okay. So anyway, yeah, if I were you, I would actually master velocity approach. I mean, velocity analysis approach and acceleration analysis approach. I would not do instantaneous center of rotation approach. Yeah. However, we will see. I don't know. Maybe on the exam there will be like a question: find instantaneous center of rotation. Yes. Maybe. I don't know. Yes, Jason, there was a question.
Would it be better to write it like negative 13.5 counterclockwise or 13.5 clockwise?
Okay, it's up to you. Yeah. So I see what you're saying. Yes, it will be better. My answer is yes, it will be better. I do it like that, which is worse. You can do it whatever you want. You can do however you want. Okay. Okay. Example number 2. Or is there any other question? So let's do example number 2. As usual, please familiarize yourself with the problem statement before we start our solution. Okay, so what do we have in here? We have only one body, yes? We have this disk, and that disk rotates without sleep on this bar. And we also have a rope here, yes? A rope that is wrapped around our disk. And we know that acceleration of point D and velocity of point D are AD and VD respectively. Geometry is known. Velocity of D is 8 inches per second. Acceleration of D is 30 inches per second. They ask us to find accelerations of these 3 points, A, B, and C. Without further ado, let's dive straight into our solution. We're going to start with velocity analysis. Why will we start with that? Because I would like to learn what is omega of the body. This is our goal. Okay, this is our goal right now. Finding omega of the body. So let's do velocity analysis between which 2 points, guys? Which 2 points you would like to run the velocity analysis? Just to, because we know velocities of 2 points on that body actually. Scott, this is related to your answer from like half an hour ago, but you don't have to answer if you don't want. So I would like to like velocity analysis between something and something. Anybody? Jason? A and B, yeah. So it can be A and B or B and A, whichever. In my notes, I have between A and B. So I can write velocity of A is equal to velocity of B plus omega of the body times RAB. Okay, so there is no sleep at point A, so velocity of A is 0. no sleep. Velocity of B will be minus 8, 0, 0, plus 0, 0 omega body, let's assume positive direction, times this vector. Okay, and that vector will be 0, 0, and something at the y component. Okay, this will be 5 minus 3. Okay, so let's do this determinant. Let's not do it. You know how to do it. So the answer will be, here the answer will be minus 2 omega body 0, 0. Okay, so we ended up with minus 8 minus 2 omega body 0, 0. So that means that our omega body is equal to 8 divided by minus 2, minus 4. Does it make sense? It makes sense. Radians per second. So it will be omega body is equal to minus 4k radians per second clockwise. Okay, we're done with velocity analysis. Now acceleration analysis. But maybe before writing acceleration analysis, you guys can tell me maybe, because we must actually find these 6 values, yes? This one, and this one. Can you guess some of them immediately? For example, what is this value? ABX. ABX, B is here. Yeah, it's exactly acceleration of D, yes, exactly. So this will be minus 30. Yes? I believe so, yeah. How about this value? Oh, not this one. This value. AY. Oh, no, not this one. AX, sorry. My mistake. This one is 0, yes. Due to no slip condition. Yeah, this is no slip condition. Okay, so instead of 6 values, we will have to find 4 only, yes? Okay, let's do acceleration analysis between A and B. So we can write AA is equal to AB plus alpha body times RAB minus omega body squared RAB. Okay, so AA was what? It was this vector. And this is equal to this vector you told me. Plus 0, 0 alpha body. Let's assume that it rotates counterclockwise. Times 0 minus 2, 0. Minus, minus 4 squared. 0 minus 2, 0. Yes, Kyle?
Why is it minus 2?
Because it should be plus. From A to B, it should be plus, yes. My mistake. Of course, not my mistake. I was just trying to figure out if you're paying attention. No, of course, I made a mistake. Yeah, it's plus 2. Sorry for that. Okay, if you run this determinant, you will end up with -2 alpha body 0, 0. Yeah, just a digression for the exam. I don't know what will be on the exam, but this determinant, look, is exactly the same as this determinant. Do you see? These two vectors are exactly the same as these two vectors. But in here we have just omega, in here we have omega. Yeah, in here we have omega, and in here we have alpha. Yeah, so just you can save your, it's a trick for you for the exam. You can save your time. You can save your time, yeah? Once you are done with this determinant, yeah, just replace omega body here with alpha body. Do you see that? Okay, so trick for you. Keep in mind, keep that in mind. It saves time. It saves a lot of time. Okay, yeah, as you can see, this is my job, yeah, to help you succeed. Yeah, okay, so now we end up with 0, ay 0, and this is equal to -30 -2 alpha body. That's it. And in here we will have aby -32. Yes. Okay, so from the first equation, we can find alpha body, yes? So alpha body will be -15 radians per second square. So it will be alpha body rotates clockwise, yes? Okay, and from the second one, we have this expression. We cannot do much with this expression right now. aay is equal to aby -32. Okay, we are done with our first acceleration. So now, what? Really? Oh yeah, okay. Yeah, okay, everything's fine, yeah. So now let's do exactly the same. Let's do acceleration analysis between points A and D. And let's see what will happen. A and D. So let me scroll up the board. We're going to do acceleration analysis between these 2 points. Okay. So this is R, A with respect to D. Okay. Excuse me? Aha, so point E, let's say. You're right. My mistake. So E. Okay, and can you tell me something about acceleration of point E? It can only have this component, yes? AE is AE 0, 0. Do you see that? Cool. So this will be E. Sorry, Kai, and thank you for your eye for detail. I skipped that. Yeah. So we'll have AA is equal to AE plus alpha body times RAE minus omega body squared RAE. It's really tedious, actually. I agree with you guys. So I think we found that was 0 AAY 0. we found that this die is AE00 plus 0, 0 minus 15 times this die will be, I believe, 0 minus 3, 0 minus 3, 0 minus 4 squared, 0 minus 3, 0. Okay. And in here, and if you do everything, you will end up with 4500 here, and we will end up with such expression: 0 AY 0, and this is equal to AE plus 45, 48 in here, and 0. So triumphantly, we know what is AE. It is exactly minus 45 feet per second square, or inches per second. Is it inches? Inches, yeah, sorry guys. Inches per second square. And AAY is equal to 48 inches per second square. Yep. Yes, Ty?
Was that 45?
No.
Double negative and then K cross check.
Let me see. So it rotates clockwise. So it seems like since it rotates clockwise, it's not. Okay, especially for you, let's do it. Maybe I made a mistake at home. It seems like you're right, yeah? No, yes? Yeah, it seems like you're right. So negative 45, yeah. So that will be positive. Clockwise. So it's clockwise, so it is positive, yes. Okay, thank you, you're right. Okay, so we found our AA, yes? So we can plug this value up the board, yeah? So this will be 48 in here. Great. And now we also have ABY, yes? Because there was a connection between AAY and ABY, yes? So now if we plug 48 in here, we'll end up with ABY equal to 80 inches per second square. Okay, so we can put 80 here. Okay, guys, and I think that it's already 10:44. We have like, no, it's already 10:45, so we should finish. Can I steal 60 seconds from your time? Okay, so what's the next step? Just run again one more time acceleration analysis that is very lengthy. Yes, let's say between points C and A. So let's say maybe this one, between these 2 points. Yeah, I choose point A. You can choose point B. You can choose this point. Yeah, you can run this analysis. Anyway, it's good to run analysis with respect to point you already found. Yes, so we found this vector. So let's do that. So I would write axle analysis between C and A, and if you do that, you will end up with AC equal to minus 35, minus 75, 0 inches per second square. Questions? Yeah, I told you we're gonna do it 26,000 times, the same equation, yeah? Okay, happy holidays. Bye-bye.